All right, continuing with section 6.1 on solving systems by graphing, we're going to talk about a couple special situations. So it still goes under the same goal of solving systems of equations by graphing. Um, and just to recap a couple of things here, a system of equations is when you have two or more linear equations, right there, two or more linear equations. And a solution to a system of equations would be an ordered pair that makes both of them true. So we're trying to find an ordered pair meaning one x and one y that works for both equations. Um, so what we did last time was we chose to graph the two equations and see where they cross, because that would be the ordered pair that they would both have in common. So we did that with one that was nice and in slope-intercept form. We did that with another one that was not in slope-intercept form, so we changed each of them, going back to last chapter, how to change each of them to slope-intercept form and then graph them. All right, so we're going to look at a couple situations that are going to be unique. So let's look at this first one. It just says, what is the solution to the system used to graph? All right, so we're going to graph. Um, let's first make sure they're both in slope-intercept form. So this one is, we have y equals 1/2 x plus 1. I'm going to actually take this one, we'll use this one in blue and bring this over here. So there's one of them. But 2y minus x equals 2. We got to solve it for y. So let's get rid of this minus x. We're going to add x to both sides. 2y equals, we'll put the x part in front, positive x plus 2. Alright, and then we'll divide by 2 to get that y by itself. Divide by 2 over here. So again, when you divide by 2 in the two parts here, we end up with y equals, this would be like 1x over 2. So it would be 1 over 2x plus 2 divided by 2 would be actually 1. Alright? So you might notice something about them right away, but let's graph them just to see. So we have this first one, the b is 1. The slope, where the rise over run, is 1 over 2. So we're going to start at the y-intercept, the b, the y-intercept of 1. We'll go up 1 and over 2 because our rise and run would be 1 over 2. And there's our lovely equation. Alright, second one in blue, we have the same y-intercept. The b is 1, the slope is 1/2. Interesting, they're both the same. So the b is 1, up 1 and over 2, up 1 and over 2. Same exact lines. Other than those two colors making us remind us of Superman, what else does this tell us? Well, there's not just one ordered pair that they cross at. There's infinitely many. They go on forever. They're the exact same line. And that is a case of infinitely many solutions. It's also the same thing as an identity when we were dealing with just one equation. Alright, so there's an infinite number of solutions for this one because they're exactly the same. Alright, let's look at a different example that's a unique one. This one right here, we have y equals 2x plus 2 and y equals 2x minus 1. They're both in slope-intercept form already. So we'll just work with this. We'll say we'll do, oh, red and blue could also be Spider-Man. Totally forgot. Anyway, we'll use green and black. We'll make the Hulk here. Um, so the first one we have in green, we have the m. What is supposed to be green? M is 2. Ah, the m is 2, or 2 over 1, and the b is 2. So we're starting at 2. Slope-intercept starting at 2, 2 up there. We go 2 over 1, up 2 and over 1, up 2 and over 1, rise over run. There's our equation. Alright, second one in black, you'll notice it has the same slope. We learned last chapter that same slopes mean parallel lines. Y-intercept is -1, because there's a minus sign. So we start at -1, go up 2 and over 1, up 2 and over 1, up 2 and over 1. You might think they're going to cross, but in reality, if they have the same slopes, they never will cross. They are parallel. If they never cross, there's never going to be an ordered pair that would work for both of those, meaning there will be no solutions for this one because they never cross. So there's no solutions. And these actually make up a couple situations, or the three situations we've done. We've done where there's one solution, where they cross at one example. They intersect at one point. And we've also done with the exact same lines. That would be infinitely many solutions. These two examples right here, these are called consistent systems. They're consistent systems if they have at least one solution. They have one or infinite solutions. The other situation is when they're parallel. These are called inconsistent, meaning there are no solutions in inconsistent ones. All right? So inconsistent. I'll stop moving around on me here. Right there. Whoops. There we go. Wow, that's just going crazy. But consistent versus inconsistent. And this is a chart if you're not sure. Well, either way, this is a great chart to have. It tells you the three different types of solutions to systems of equations. Okay? So that would be the unique situations. There's one other problem. Well, yeah, we'll do that one a different time. All right. So that's the second part of solving systems by graphing those two unique situations of no solutions or infinitely many solutions.